In this lesson, we're now going to talk about adding and subtracting rational expressions, which is really adding and subtracting fractions. And so if you recall from your past, when you had to add fractions, you probably were told you had to find a least common denominator, or an LCD. We're going to do the same with rational expressions. And so we're going to start by practicing finding what we're going to call the least common multiple, but this is really the same thing as finding a least common denominator. So basically, the least common multiple is the smallest number that contains all factors of the numbers given. In other words, if you think at or look at example A, we are trying to find some number that's divisible by 10, also by 15, and also by 9. What number is divisible by those three numbers? And some people can do this in their heads, and that's great. Really just takes knowing the times table really well. But I'm going to show you how you can find a least common denominator by writing out factors. And this is going to be really helpful when we get to problems with variables, with x's and y's in them. So one method you can use to find a least common multiple or least common denominator is you find all the factors of each number. So 10 is 2 times 5. And I know 15 is 3 times 5, and 9 is 3 times 3. Then the idea is your least common multiple, or least common denominator, has to contain every factor of every denominator. So I just start at the top and work my way down. So 10 has a 2 and a 5, so I have to put the 2 and the 5 in my least common multiple. And so then you could maybe underline or cross off, we have a 2 and a 5 in our least common denominator. So then moving down to the 15, I already have the 5 written down. I really just need to add the 3. So now I put the 3 in there. Okay, so now the 3 is in there. And then moving down to the 9, well, I already have one 3, so I just need to add one more 3. There we go. And now I have all of the factors in that least common multiple. The 2 and the 5 is the 10, the 3 and the 5 is the 15, and the 3 and the 3 is the 9. We can multiply these numbers together, and that'll be our final answer. 2 times 5 times 3 times 3 is 90. And it is true that 90 is divisible by 10, 15, and 9. So let's do the same process with some other examples that have variables. So we can do the exact same thing with 6xy and 18x squared. 6xy, 6 is the same thing as 2 times 3. And then we've got an x and a y. Now the 18, well, 18 is 3 times 6, and 6 is 2 times 3. So that 18x squared is 2 times 3 times 3 times x times x. All right, so least common multiple. I'm going to start by just copying down everything in that first term. So I just copy down the 2, the 3, the x, and the y. And then I go to the second term. I already have the 2 and the 3 written down, and I have one of the x's written down. So the only thing I need to add here is I need another 3 and another x. And then if I multiply all of this together, let's see, we get 18x squared y. And that's my least common multiple. Now, for some people, you might be able to do this in your head, and that's great. If so, you don't have to show any work. How I would do this one in my head is, really, I just look at the 16 and the 18 first and think about, well, what can I divide by both 6 and 18? The answer is 18. And then I would pick the variable with the larger exponent. So we need the x squared, and then we have to have a y. If that doesn't make sense to you, you can always write it out like I've just done and get the same answer. Now, as soon as we have expressions with plus or minus signs, sums or differences, finding those factors is now going to mean all of those factoring skills we learned in the previous chapter. So now it's not going to work to just write x times x. Instead, we've got this x squared minus 4. Because there's a minus sign, factoring means looking for GCFs, looking for special patterns. In this case, this is a difference of perfect squares. And then the 5x plus 10, that one has a GCF. That's 5x plus 2. And then I can use the same process to find my least common multiple. I'm just going to write down all the factors from the first term. So we need an x plus 2 and an x minus 2. And then I move down to the second. I already wrote down the x plus 2, so I just need to tack on a 5. And I'll put that in the front because it looks a little nicer, but it doesn't matter where you put that 5. All right, so that's the process of finding a least common multiple or least common denominator. And so that process is going to be really important if we want to add fractions. And so let's just first review, how do we add fractions with numbers? So 7/12 plus 3 over 20. First thing we have to do is find the least common denominator. So I know 12 is 3 times 4, and 4 is 2 times 2. So 12 is 2 times 2 times 3. 20 is 4 times 5. 4 is 2 times 2. So 20 is 2 times 2 times 5. Denominator, I need a 2 and a 2 and a 3. That came from this first denominator, 2, 2, 3. I already have the 2 2's written down, so I just need to tack on a 5. So 2 times 2 times 3 times 5, I think that's 60. Yep. So my least common denominator is 60. And so then the idea is I need to rewrite each fraction so that it has a denominator of 60. And so to turn a 12 into a 60, I have to multiply by 5. And so I'm going to do that to the top and the bottom. To turn a 20 into a 60, I have to multiply by 3. So I'll do that to the top and the bottom. And so now I have 35 over 60 plus 9 over 60. Now we can add the numerators. Denominator stays the same. So 35 plus 9 is 44 over 60. And then I guess we should reduce. I think I can divide by 4. 44 divided by 4 is 11. 60 divided by 4 is 15. And there's my final answer, 11 over 15. All right, so let's try this process with rational expressions. So first thing I have to do is find the least common denominator. In part A, my LCD needs a y, it needs a 2, and it needs an x. So that LCD is going to be 2xy. And so now I'm going to just rewrite the problem, but I need these fractions to have that common denominator. So I'll take the first one, the denominator is missing the 2x. I'll multiply top and bottom by 2x. Second one is missing the y, so I'll multiply top and bottom by y. And so now I have 6x squared over 2xy plus 5y over 2xy. And then we're going to add the numerators, although in this case these are not like terms. We can't combine them. So we just leave the numerator as 6x squared plus 5y, and my denominator is 2xy. And that's it. That's my final answer. I can't factor the top, so I can't cancel anything out. And that's it for part A. Okay, part B, my LCD. So I have a denominator of x minus 2, so I have to have an x minus 2 in it. I have a denominator of x plus 5. That has to be in my LCD. So that means the first fraction is missing the x plus 5. So I'm going to have to multiply top and bottom by x plus 5. Okay, and then the second fraction is missing the x minus 2. So I'm going to have to multiply top and bottom by x minus 2. And when I do these problems, I always FOIL out or multiply out the numerators, because that's where I'm going to do the adding and subtracting. But I usually don't multiply out the denominators, because once I find that LCD, it's not going to change. And in fact, I like having it in factored form. So I'm going to FOIL out the numerator of the first one. So I get x squared plus 5x plus 4x plus 20. And then sometimes if I'm feeling a little lazy, I just write LCD for the denominator, and then I'll fill it in later. Okay, and then the second one, x squared minus 2x minus 7x plus 14. And that is over the LCD. And we should probably combine like terms. So x squared plus 9x plus 20 over the LCD minus x squared minus 9x plus 14 over the LCD. All right, so now we're ready to do the subtraction. And with subtraction, we have to be a little bit careful because that minus sign is actually going to apply to everything in the second fraction. And so I'm going to take the time to actually distribute it. So I'll finish my work over here to the side. So I've got x squared plus 9x plus 20. And then it's going to be a minus x squared plus 9x minus 14. And this is going to be all over that LCD. All right, let's see. The x squareds cancel out. And then we've got 9x plus 9x. That's 18x. 20 minus 14 would be a plus 6. And I think I'm going to finally fill in the LCD, which is x plus 5, x minus 2. All right, and that is actually the final answer, although I'm going to check and see if we can simplify. And by that, I mean I usually like to factor, if possible, just to see if there's any common factors. And in the numerator, we could take a 6 out, and then we'd be left with a 3x plus 1. But that means there's nothing I can cancel. There's no common factors. And so you can leave your answer in this factored form, or you can keep it as the 18x plus 6. Either way works. All right, let's do one more example. So my denominators are, let's see, we've got a denominator of x squared minus 2x and another denominator of x squared minus 4. So finally this time I actually can factor the denominators, and I should factor them. The first one we can just pull out an x, and we're left with an x minus 2. And the second one is a difference of perfect squares, x plus 2, x minus 2. All right, so the LCD has to contain the x and the x minus 2. That's the first denominator. And then from the second denominator, we've already got the x minus 2. We just need to tack on the x plus 2. So my LCD is going to contain x, x minus 2, x plus 2. All right, so I'm going to copy down the problem, but in factored form. We've got 4 over x minus 2, and we are adding x over x plus 2, x minus 2. So the first fraction is missing the x plus 2. We'll multiply that by the top and the bottom. And the second one is just missing the x. All right, once again, I always distribute in the numerator. I never distribute in the denominator. So my first fraction is 4x plus 8. And I'm going to be lazy again and just write LCD on the bottom. The second one is going to be an x squared over the LCD. All right, so now we add the numerators, although there's no like terms, so I'm just going to leave it as x squared plus 4x plus 8. And I'm going to fill in that LCD now, x, x minus 2, x plus 2. And we should check, can we factor the numerator and cancel anything? Well, 8 could be 8 times 1 or 4 times 2, but I can't get a 4 out of that. So I can't factor the numerator. That means this is my final answer. All right, that's my last example for this week. Please let me know if you have any questions as you work through the homework.